screen.
Yeah, sure.
Yes, I think we are all set now. Let us start this very interesting webinar. So, ladies and gentlemen, good evening to those who are in India and Japan, and good morning to the other side, US and Europe. So welcome to all of you to MIJSC at IIMB Katsujin Speak webinar lecture series. My name is Saideep Ratnam. I am the Chief Operating Officer at MIJSC. This center, Mizuho India Japan Study Center, is a center of excellence at IIM. And the focus of this center is primarily to strengthen India and Japan bonds by promoting academic, industry, and societal linkages. This webinar series actually is one such attempt where we are bringing in experts from both the countries to talk on societal, technological, business, and other facets of life, which highlight both Indian and the Japanese perspectives. This actually is the 17th in this series. We started it in the middle of the pandemic. And we have with us today Mr. Jayaram Balasubrahmanyan. He's the Vice President of Engineering and Head of India Operations at Atonarp Microsystems. He is, of course, based in Bangalore. So that is why today he is with us at the campus. I have great pleasure to welcome Mr. Jayaram. Jayaram has held senior leadership positions in engineering field for over 35 years. In fact, his experience is very rich, both in techno-commercial leadership and also in designing and implementing products and engineering solutions. And of course, he has been in functional leadership areas, driving lean businesses and talent transformation. So this company, Atonarp Microsystems, is a startup based in Japan, which is focused on advancing clinical diagnostics, life science research, semiconductor and industrial process controls through digital and molecular profiling. It's a very developing field, very exciting field. Prior to this particular assignment, he was heading Rolls-Royce Aerospace Product Development and Technology, again based in Bangalore. His professional experience is more or less equally divided in project execution and product development. So his engineering experience includes industrial automation as well as aerospace. So very interesting profile. And during these years, he has covers design engineering, commissioning, operations, product development, and of course, projects. And he has worked in a variety of industries, starting from petroleum, paper and pulp, power, dairy, sugar, pharma industries, amongst many others that he has worked on. He's a pioneer, in fact, and I have really enjoyed my interactions with him, and I'm sure you will too this evening. He's a pioneer in conceptualizing and deploying lean transformation in this area of product development with the objectives of a sustained business excellence. He's an alumnus of IIT Madras and IIM Kozhikode. So welcome to this forum, sir. I would like to set the context for the discussion for today. The theme will be, as I have mentioned before, developing products the lean way. And he will share with us the counterintuitive learnings, which will help industry in general. The objective of this topic was to introduce lean product development, a concept which was initiated by Toyota, but you can call it the secrets of that are quite hazy, as Mr. Jayaram will share with you, because they never really, like they opened up the TPS, production system, they did not open up this key elements of Toyota's lean product development. So that Mr. Jayaram will talk, his talk actually will try and demystify this area and bring out some key differences and approaches which are counterintuitive at first glance, but have a significant impact on the deeper analysis and practice of product development. So this actually session, I hope, will prod a product developer or a technology leader or even a business leader to investigate and consider the deployment in a systematic way so that the full benefits of lean product development is visualized and achieved. So over to you, Mr. Jayaram.
Thank you, Mr. Saideep, and namaste, namaskara, everyone. So let me fire up my PPT here.
Yes.
I hope you all can see it.
Yes, we can see.
Okay, thank you. So today's topic is on lean product development, and Saideep has given a good introduction, so let me just start off. So why develop new products? Now think of a business situation where you have a product which is meaningful, saying that the customer is willing to pay a premium. It is unique in the sense that it is difficult to replicate and it has the right velocity, saying that we have a system which is more proactive and reactive to customer needs. So what does this mean? This is actually a definition of a new product. Today's talk will be predominantly on B and less of A and C. A and C is more about innovation. I'm an execution guy, right? So I'll be talking more about B, of course, touching about A and C a little bit. The approach is more from the context of, from the perspective of lean product development, where I'm going to talk about what should be done, what comes on the way, and what sometimes seems right, but should be reconsidered. Now, what is attractive about lean? As you all know, lean got originated from the Toyota production system, mostly meant for production. However, when it is deployed right, it gives some significant outcomes. The safety, quality, flexibility, throughput, and people engagement capability increases at low cost and lower inventory. It may sound very, how is it possible at all? So there are seemingly conflicting objectives. Like, for example, you have low inventory but high flexibility, low inventory but high throughput. How is this possible at all? This is through what is called lean principles, which I'll talk through a little bit because this is going to be relevant throughout this talk. The number one step is identify the value from the customer's eyes, from the company point of view, from each function point of view, from each activity point of view, and from each individual point of view. Everyone knows who is their internal customer and their external customer. Then map your work in terms of value stream, saying how it starts and how it reaches your customer. And also observe what adds value and what does not add value. In the parlance of lean, it is called waste, eliminate it, and do your work so that it reaches your customer in a straight as a flow, which is point number 3. Having created a flow, do your work depending on the demand of the customer needs, which is the pull, and seek perfection. Seek perfection meaning that a business is an ongoing entity. The technology changes, the customer changes, the customer demand changes, the leadership changes, the people changes, but the company should go on. So there has to be a continuity in this, a sustained system here, which is done by what is called as a PDCA, which is the heart, which is the basic mental model beyond this. Now, how does these principles gets converted into action? It is by what is called as a Toyota House of Quality, which is, you can see a lot of these words here. These are all the various systems which enable the Toyota production system. Now, having looked at this is a very well researched, published, and applied in many across the world, a lot of it in India, but these benefits are so essential. Can it be replicated in product development also? Can we just lift and shift the whole system into product development and make it work? In order to answer this, we need to understand what is the difference between manufacturing and product development. In manufacturing, the end product, the specification, the process of manufacturing, the skill to manufacturing, it's all known. Whereas in product development, it starts in a very fuzzy way and evolves as the product gets developed. In manufacturing, it's a material flow and a single piece flow where a material flows and so many things gets assembled and you finally get a product. In product development, it's a knowledge flow and it's a swim lane flow, meaning that there are multiple functions which function simultaneously, concurrently, collaborating with each other, and finally a product happens. To continue on this, product development is skill and process driven, whereas product development is knowledge driven. We'll talk a lot about it. Knowledge, because a lot of decisions needs to be made. In manufacturing, the inventory is visible. Product development, it is invisible queues. Manufacturing, defect is a waste. In product development, it's a big learning so that you don't repeat it and you don't insert it into the product. Less I don't knows in manufacturing, a lot of I don't knows in product development. Variations are bad in manufacturing. That's why you have all the systems called Six Sigma. In product development, variations bring value to the business, especially if the customer wants those variations. Absorbing them is the right thing to do. So if you summarize in a way, following the defined process with the defined skills, with defined raw material, manufacturing system, there's a high possibility, high probability of manufacturing the specified product. Whereas in product development, you have to iterate towards the right product. So if you look at it, each one is unique and complex in its own ways, but the fact is they are unique. So we may not be able to lift and shift the existing system. So we need to understand a product development a little bit better. Okay, product development, right? When you say product development, the nature of product development, the first thing which should come to your mind is called cone of uncertainty. You see a picture here on the left hand here. Typically, product development is represented like a cone, where in the initial part, when you start doing the work, there's a big decision space and less knowledge. And that is called the uncertainty. Gradually, you grill down and come here to a place, you take more, learn more, take more decisions, and come to a space where you have a small decision space, but more knowledge. This area is called the fuzzy front end, right? And it's very, very important to handle the fuzzy front end in the right way. If you see the graph below, the concept phase where the fuzzy front end gets addressed, just less than 10% of the cost of the project is spent, but 75% of the cost of the product is determined by the decisions you take here. So we need to be very careful and very focused to deploy the right capability and the capacity to cross the fuzzy front end in a very effective way. The decisions you take here are going to be very, very important. Talking about decisions, the common mistakes what we do here is try to overlook the uncertainty and try to be specific. The whole fact that it is uncertain means that you cannot be specific. Forcing yourself to be specific, maybe to meet some timelines, is a common mistake. Making decisions without validating from the market, before the solution is proven, and before the limits, trade-offs, causal relationships are well understood. If you do this in haste during the cone of uncertainty, then these mistakes can be fairly or typically very, very expensive. So if you look at it in the graph here, in product development, there is a terminology called factor of 10. If you do a mistake in concept phase and don't fix it, and the mistake gets carried on to the design stage, it will cost you 10 times more to fix it. If it slips to the development stage, it will cost you 100 times more. So the cost of doing things thoroughly in that particular phase is very much essential in a product development context. Now let us get familiar with some terminologies, because we are going to use it more often in the next 1 hour. Uncertainty, we just talked about it. It is a knowledge gap. Variability. Let us say we have addressed all the knowledge gaps, but still due to business reasons, the customer will ask for variations. Your own business will ask for, customer will say, I want this to be less heavy, the weight should be less. Your own business may say, you know what, I want the cost to be 10% less. These variations will happen during product development. The product development system should make best use of the variability to drive the business. It shall absorb the variability. On the other way, resisting variability kills innovation. And we talked about the cost of defects. And it's very, very important that we mitigate a lot of uncertainty in the fuzzy front end. And usable knowledge. All of us, what is usable knowledge? Having the right knowledge at the right place at the right time to mitigate the uncertainty and absorbing variability is called usable knowledge. All of us send our engineers for training. They build skills. But what sort of knowledge or learning they need to have in a product development context is something called an integration learning. As much as they know what to do, they should also know the context, meaning that they should know how the work came to them and how they added their value and how it is going to be utilized. Understanding this whole value stream is called integration learning. Then innovation learning. Given a problem, coming up with multiple possible solutions. Then feasibility learning. Given multiple solutions, how do you narrow down to the right solution? These 3 learnings are very essential to be a successful product developer. Now let us talk about, till now we talked about the nature of product development. Now we'll talk about some specific about the solution part. So what is value in a product development activity, right? So let us say you have a function or a group of people doing some work. It can be called value if the output of the work is something which the customer cares. It determines the form of the product. The effort minimizes uncertainty or absorbs variability and results in producing usable knowledge. If all these things happen, then that effort is called value from a product development context. If none of this happens, in a lean language, it is called pure waste. If some of this happened in a lean language, it is called required waste, right? Now, next about, this question always comes. Design and test versus test and design. Suppose you go and ask somebody, how do you do a design? I design, then I build it and I test it. If somebody says that, actually that means they are overlooking the fuzzy front end, because when they do their design, it looks like they know all the answers. But lean product development says, first ensure that you are doing the right thing. Test and experiment, repeat until feasible. When you are sure that your concept really works, then design, build, test, and scale up. So this would be my side. This is the approach of lean product development, what you see on the right-hand side. And another key concept in lean product development is concurrent engineering. Even though typically product development process is given like this, in reality, the execution happens the way you see here. You see various functions, they work simultaneously, concurrently. Each of them have an uncertainty cone. They address it, they mitigate it, and finally you get the great product. More importantly, if you see here, the manufacturing system starts as early as anything. Normally, when you see people say, I do the design and I transfer it to manufacturing. But if you see this model, the manufacturing starts right from the beginning. They observe the whole evolution of the product, because how much ever well you design, unless it is manufacturable, it is actually almost meaningless. So this is called concurrent engineering, one of the concepts in lean product development. Then couple of more points called set-based design. In the earlier slide, I talked about decision making. Now in lean product development, there's a guidance on how do you make decisions. It is called set-based design. This is something we follow in our daily life a lot, but we should really try to do it in a product development context. Given a problem, you don't take one solution, but take multiple solutions, look at each one of them, see the best of everything, try to see if you can combine them, try to see if some of them can be eliminated, and take the best of everything and eliminate what is not required and come to a final solution. This sort of an approach is called set-based design. Now the beauty of this approach is not that you have taken the best option, you also know where you have eliminated certain things. Where this helps you is later on in your product development, when your customer asks for a variability, you can go back to your notebook and say, you know what, I eliminated this because of this drawback, but that is now coming handy. Can I bring it in? So doing the set-based design helps you to absorb variability. It may look to be a very expensive, costly way of doing it, but it's a very effective way of doing product design. Then this debate comes, efficiency or knowledge, which I call it effectiveness, right? If I go to a product development site and if the leader says he's very proud of his productivity, I feel pretty scared. Okay, when you are handling a scenario with uncertainty, how is it possible at all to be so productive, right? So this is just like the Bannerghatta road, right? When there are not too many people in the road, you can go really fast. Even if there's a bus stops in the middle, some auto comes in, a dog runs across, you can just navigate and flow. But imagine when the road gets utilized more, your delay gets more. Same queuing theory applies to product development as well. So when you load your people, if you load them beyond the limit, then your lead time only increases. You should give some flexibility for people to handle the uncertainties as they realize it during the course of product development. So if I have to summarize this, product development is about uncertainty, so difficult to scope evolves, difficult to size, difficult to estimate. So if the utilization is high, then it would actually mean the velocity is low. With this background of what nature of product development and some key aspects of lean product development, let us see what is called the essence of lean product development as seen by Toyota. Okay, this is called the second Toyota paradox, right? Why is it called a paradox? Before we talk about the second Toyota paradox, let us talk about the first Toyota paradox. The first Toyota paradox is what is called as a production system. It says certain things which is very different from what was done earlier, which is called mass production, where volumes mattered. Whereas in Toyota's production system, they said delivering just in time. Actually, this means you can be more flexible. Breaking down below minimum economical quantity. This actually probably means flexibility, right? Then worker rather than professional inspectors check previous. So there's no experts. People are accountable for their work. People actually know what they are doing. It is respecting people and making people more capable. On the same lines, any worker can stop the line and in fact, it can stop by itself, right? That means what matters is quality. If there is no quality, there is no product. And everyone in the system is accountable for doing that. There is a system like this. Then adding many tasks to a single workstation, flexibility, capability. Then people redesign their own work. You don't need some expert engineers. So the whole system is a combination of the right people, energy, and the right systems in place to deliver this. Now, if this is the first Toyota paradox, which is very different from the earlier mass production, what is the second Toyota paradox when it comes to product development? So here are the 4 bullets. It is set-based concurrent engineering, which I talked, which is like work on multiple options before you actually choose the right one. Then delaying decisions is a very important part of product development. Delay your decisions till your last responsible moment and not 1 second later. The purpose of delaying is you make use of the time to learn as much as possible, to mitigate as many uncertainties as possible, and really know how I talked about limits, trade-offs, and causal relationships. You really understand and record them very well so that you can make your design much more robustly. Communicate ambiguously. Of course, when you have more uncertainty, communicating with specifically actually is misguiding. You have to be talking ambiguously to the level of ambiguity which others understand. So there's very seriousness, there's practicality about how we take up your work. Then pursuing excessive number of prototypes. So this may look expensive, but eventually this enabled Toyota to design better cars faster and cheaper. So if you look at these 4 points, it may look to be inefficient and conservative, but it brutally, honestly coherent with the paradigm of product development. So this is called the second Toyota paradox. Now, I'll go further into some more specifics, saying that, as Saideep said, Toyota production system is well researched and well published, whereas Toyota product development system is what people went, saw, observed, recorded, and proposed. So I'm going to talk about 3 such approaches to lean product development. One is, and people have written books. I'm going to refer 3 books here. One is the book called The Toyota Product Development System by Jeff Liker and James Morgan. And what he says is, what does the system do? Its system creates a level product development flow, adapting to technology to fit the people. So the key word here is flow. And the way he represented this is in terms of 13 principles. And actually, you should read this book. It's a fairly very detailed book. It took me 3 months to read it. And eventually, the principle of what he says is that it's a whole system by itself which is required to develop a product in a lean way. That means it's an integrated effort among sales and marketing, design, purchasing, engineering, manufacturing, suppliers, everybody working towards a single objective with the right systems in place to deliver it, which actually means that it's not just enough if you follow lean in design and in manufacturing. The whole organization should be thinking in the lean way so that the work happens in a more coordinated way. There's a second approach, which is written by Alan Ward and Mr. Sobek, which is the book named Lean Product and Process Development. So they say, what is the objective? Here again, they talk about flow. They say, if you have done a great product development, that means once the customer orders the product, the flow from supplier to production to product to customer should happen in the most profitable way. And how do you make it happen? So they call it as 4 cornerstones of LPPD. The first one being chief engineer. There's one person who is accountable for the techno-commercial success of the product. He's a very nerdy person whose only aim in life is to make the product successful. He thinks, sleeps, fully lives in that product, and he really knows how the various things work. He coordinates the engineering decisions to make the product. And he is supported by this team of responsible experts who have various functions, like mechanical, electrical, all these other things, who have deep functional expertise and who actually make the vision of the chief engineer possible. When so many technical people work together, there are so many things which can fall through the gaps. So you have the second thing called cadence, flow, and pull, which brings in the discipline of product development. With these 3 things in place, we should be able to make the right decisions, which is the 4th pillar called the set-based concurrent engineering. So this is these two books are excellent books. You should read it. It is much more easier to read than the first book. And as they propose this, they actually talk about few things which actually talks about why lean product development is different. In a conventional system, we be as specific as possible. In a lean product development, you take rough targets and actually narrow it down. The design decisions in the conventional system are taken as early as possible. In LPD, it is as late as possible. Testing is mostly after design in conventional. In lean product development, it is before design. It is test and design. And project management is administrative and conventionally. In lean product development, it is done by the most technical person in the organization called the chief engineer. And in terms of manufacturing involvement, conventionally, we think the manufacturing follows the advice of receives the design and manufactures. In lean product development, the primary driver is the design decisions which makes the product. Because unless you are able to manufacture, there's no meaning in designing something. Then there's another important point called cycle time. Okay. Now, what is the total time for a product development? Reaction time, which is basically the time from the instant the customer expects something to the time when the business is investing on it. Okay. Exploration time is the fuzzy front end, what we talked. Lock-in time is the detailed design and manufacturing. Fix-up time is the launch time, going and fixing all the problems after it's getting deployed inside. The key thing is here is the reaction time. It's a time between the opportunity and the company deciding to invest. If you look at this number can even be negative. Okay, that means you can start well ahead if you are really understanding the customers, the mood of the customers, the technology. You can actually make this start earlier. So in terms of business parlance, this is called technology roadmap and business roadmap. These two things are very, very critical in a business environment. And this should actually make this time as negative as possible so that you should be ahead. You should be able to give a solution to the customer even before they want it. So I would really emphasize, put a lot more due diligence in your technology and product roadmaps because they make a big difference from a new product development perspective. Then there's a third perspective to lean product development by this person by name Ron Reinitsen. So his point is very different. He said, what all people have been talking about lean development is wrong. It is not just little wrong, it is totally wrong. Okay. So he says, to make flow, you have to manage queues, not timelines. Okay. In other words, timelines are outcomes, queues are the inlet. So if you manage queues, you'll get time. And there are various other points he talks about. Now, I just talked about three approaches here. There are several other approaches. And the way I have gone ahead and done this is exactly the way I talked to you about the set-based design. Evaluated various options, try to understand everything. Here I put in the team with whom I worked with, like Tulasi Veerappan, Rajesh, and a lot of these people. We really studied, analyzed, as we did the work, experimented, see what worked, what didn't work. And I'm certainly not a thought leader, but I certainly know what works in a given context. Okay, so I would like to give an interesting takeaway, which as a techie, I've been a techie most of my life, which says that theory without application is aimless. Application without theory is dangerous. And actually speaking, most of what I told is being researched in academic institutes and published, and that's a big relief for me. So this is as an introduction, as I want to talk about lean product development, and maybe Saideep, you could open up with some questions.
Yeah. Thank you. I think you have been a very depreciatory about yourself. You're not a thought leader, but I think the way you have presented, I think it is many difficult concepts and many, as you said, counterintuitive and slightly contradictory concepts, which are the pillars of product development. lean product development. I think wonderfully summarized. Thank you. You did talk about the value to the customer in one of your early slides. So, and you did say that this is one of the attractive features of lean product development. So, but how can you elaborate as to how companies can create value by applying these principles in the context of product development or lean product development?
Yeah. So when we talk about value, the business value is, of course, making a lot of revenue and profit. And the customer value is that, and a lot of that happens if the customer pays premium to your product and he believes that the value is getting out of it is more than what he paid for, right? Now, that is what a new product development does. Now, how can this happen? How can this be created in a company? Is purely through the people, purely through the people. The company should, everyone should know their internal and external customers. The company, the various functions in the company, the various activity that functions do, and the various people who are part of the various functions. Each one should know what is value. Now, one interesting thing about lean is that as much as they talk about value, they talk about waste. That means, and there's a very important principle in lean called waste observation and elimination. In my experience of deploying lean, one topic which really took a long time to get it across to the people is waste observation. Okay. Now, as much waste you eliminate, as much focus you get on value. If this happens at every individual levels and they're empowered to talk it out, empowered to bring out the problems, then it is not a one-time answer. Gradually, the focus of the people on the value increases and the whole business will be focused on delivering value.
Great. So just to clarify the thinking, does it mean that anything that the customer is willing to pay for is value and not pay for is a waste? Is that in a way can be summarized that?
No. It is not like that.
Okay.
It is certainly not like that.
Okay.
Actually, the customer should actually benefit from the product.
Okay.
So that he believes that this company is actually serious about delivering product which matters.
Mm-hmm.
Right?
So,
eventually that would get converted to money though, but what the customer believes is beneficial to them is what, and eventually, of course, if they see value, we have to believe that they would pay for it.
Okay. So not directly, but indirectly. That's what you're saying.
Yeah.
Okay. Very good. Thank you. Based on your long experience in this field, can you give an example of or elaborate on, and then give an example on what is the reduction of waste, basically through this approach that you talked about, the lean product development?
Okay. Let me quickly share my screen again.
Yeah.
So in product development, if you go to manufacturing, when you call waste, they say .WIMP, defect, overproduction, overprocessing, all those things are called waste. In product development, waste means knowledge waste. Okay. That means we are not effectively utilizing the knowledge available in the people what we have, or the knowledge which is required to be put into the product in an effective way. When some of this happens, that means there's a waste here. This is fairly a deep subject. I'll just talk about 3 of them. The first one is called scatter. Scatter means any activity, any decision that is taken which will distract the focus of the people from delivering value, then it is called scatter. For example, let us say there's a team of 20 people working, and suddenly they say, no, I want to add 10 more people. Now, adding 10 more people is an answer to a problem. Now, if you add 10 more people who have no background of the project, you see how amount of distraction it will take place. So for the decision maker, when he has cleared the 10 people, he has actually done his action. But actually speaking, that has created reasonable amount of confusion, right? So it is not that the 10 people should not join, but we should be conscious of the scatter it creates and be able to make sure that that whole, the flow happens in an effective way. This is one example of a scatter. The second, which is the most common in product development, is called a handoff waste. As I told earlier, product development is because of so many functions working in parallel, right? So let us say I am an expert in mechanical design. So I will really know that well. But when I pass it on to somebody uses it, and they may not be the best in mechanical design. They may be good in some other design, right? So there's a handoff, there's an asymmetry in knowledge, right? So when we create some information and knowledge and put it in a repository, it should not only be understandable to the person who created it, which normally it is, it should also be in a language which is understandable to the rest. And to make it more efficient, there's something called the T competency development model, which actually helps in this whole thing, right? So here there's a vertical line, in this case, say electronics and all those guys who are very, very good in what they do. But the company should also invest in ensuring that they understand the rest of the flow, rest of the engineering to a reasonable extent, that there's enough effective collaboration. It should not, I have done my job, it is enough. It's not a great working culture in product development. It actually creates a lot of handoff. So minimizing handoff minimizes knowledge waste. And the third one is wishful thinking, which is most dangerous, right? Wishful thinking is when you do not know enough, but still go ahead and make a decision based on some of your past experiences, which is nothing wrong about that. But once you know you have made a decision without the right facts and experiments in place, be conscious that it is not a well thought out decision. Do experiments to prove that your decision is right or wrong, your hypothesis is right or wrong, and then go ahead and do it. So these are the three main components of the waste in product development. This actually goes, as I said, this is one of the deepest subjects. It takes a very long time, but I think this will give you an introduction of some idea of what is knowledge waste. I have referred to a book in the bottom. If you go and read that, there'll be a lot of things. Or if you want to call me or message me, we can certainly talk about it.
Wonderful, wonderful. Thank you. I think you have a very unique style, I must say, where you even explain simple things with a model. I think that makes it very clear to all of us the main essence of what you're talking about. As you said, there are much depth to be looked at. So in a way, if I remember right from my old knowledge, they used to say in the lean production, Tim Wood, or TIMWOOD, as you rightly said, is applicable. Some people say Tim Wood followed by a word S, letter S, which, as you said, is a knowledge based. And very succinctly, you have brought up the key element of this. So if I may prod you into a slightly different direction, and going back to the, I think early slide you had put about the principles of lean flow. Can you explain to us a little in simpler language, how can these principles, flow principles, be applicable in LPD?
Okay. So before talking about what is flow, maybe it's easier to understand what is not flow, right? So let us say you have some liquid flowing in some channel and you obstruct it. That means the flow is obstructed. Then what happens is it starts building up in one area. So one way to know that flow is not happening is if something accumulates. There's no smoother passage of something to flow. In engineering, let us say you plan to do work in a particular load, and suddenly if you see the workload increasing, okay, that means there is an invisible queue which is building up. that means the flow is getting obstructed. If that happens, I showed you this graph earlier. That means even though you have planned till the green line, this red line will catch up. That means there are some invisible things which are piled up, and you need to put extra work to make it happen. And as you go more and more on this x-axis, your delay increases, right? So this is, to understand flow, we should understand what is not flow. Okay, this is not flow. So I've given some causes which inhibit smooth flow. This is taken from a book which I have written, adapted from a book. There are a lot more reasons. I didn't want to make it more complicated. I just bought a few things. I'll just pick up a couple of activities, a couple of points here. Let us talk about knowledge waste, right? Let us say we have made a wishful thinking, which is a knowledge waste, and actually we've gone ahead with the design and some new things spring up, right? That means you have created a knowledge waste, some invisible inventory is getting built up. So you have to do more work to mitigate it, then that inhibits smooth product development flow. Then let us say hostility to variability. Hostility to variability is a very big problem in product development because variability will be there, and better face it, right? For hostility to variability, let us say you're arguing against, you already gave it as a spec, it has changed and all that. You eat up a lot of time. Finally, the business and customer make the call, right? They say they want it. And you have to anyway end up going it. So you have to make up for the lost time, and you have to go and do something more. Again, the red big arrow comes in, and you have to put more effort, which means that the flow is getting inhibited and the delay increases. So anything which contributes to this is something which inhibits smooth flow. So some of the symptoms which, if I may talk, is if people who are working excessively loaded to meet a schedule, that means you normally go and praise them and give them a lot of accolades, which is good. You should do them because a lot of hard work, they have to be recognized. But the hidden message there is, if it is taking you more time, that means some of your assumptions are wrong. There's a blindness to queue there. So there is a flow which is getting obstructed. Testing time is compromised because you take more time to design, whatever. So there's a problem there. Then sometimes the test result there's an anomaly, and you really cannot explain it and try to rationalize it rather than analyzing it. That's a very serious problem, right? Somewhere you are forcing the flow to get inhibited. It will come out some other time. If mistakes repeat, that means there's no learning in the system. Again, if it can repeat twice, it can repeat thrice. That means somewhere you're not gone to the root cause. This is a scatter problem. Handoffs to other functions, we talked about it. And if small changes takes long time to implement, that means there's no right knowledge which is allocated for the project. So your flow will get obstructed, your queue will increase. Project cost overshoot, friction between functions, unable to focus on customers. Some of these are some symptoms. If these things happen, that means the flow is inhibited. There's a rising invisible queue, and this is really not a great. So as much as we talk about the beauty of flow, it's important to understand the beauty of not having flow, which is what, as leaders, we have to go and mitigate.
Very nice. Again, you explained it using a very simple model, but also you were very clear that in a production environment, the difficulties in flow or barriers to flow are very visible, like inventory piling up near a machine or between operations. Whereas in product development, it is not so visible. And therefore, I think what you gave as a clue is extremely helpful. Thank you. Now, I will look at, because you did talk about a very important point, that employee is the person who is working is the key to value, and every one of the people working should be conscious of what value is required and what value he's adding. So in this context, can you tell us a little more about employee empowerment how it can be become the key to lean transformation in product development. Can you give also some examples of this?
Yeah. So this particular question, the answer is it's more of a lean culture. It's not specific to product development. It is applies to any activity we do as a part of lean culture. Typically, when you draw an organization chart, you put the leader on top, the supervisor on bottom, and the execution team, leader on top. So the supervisors in the middle, and the execution team in the bottom, right? That's typically you put a, so it's a triangle which comes, it's a triangle like that. In lean, you can just go and Google and see the organization is the ulta. Okay, they put, it's the same triangle, but they put the execution on top, supervision in middle, and the leaders in the bottom. The role of the leader is actually, okay, the role of execution team is how do you work? The role of the supervisor team is how do you lead and work? The role of the leader is how do you lead, work, and organize? Okay, that is the additional value which each layer brings in, and it's a ulta. That means all the leaders, the supervisors and the leader, are expected to enable and support the execution. The reason being, the people who are doing the execution are touching the product which the customer will also touch, right? So they need that focus, and the role of these leaders and supervisors are to make. And how it happens is, go to the Gemba, go to the workplace, and if somebody is stuck with an answer, make them think broad. If somebody is thinking so many answers, help them to narrow down. Okay, ask why, ask them questions, engage in discussions, bring out the facts, spend quality time, and make the person come up with an improvement and go and deploy it. So to answer you, respecting people means empowering people, right? And this is a part of the lean culture, be it product development or manufacturing or any other function.
Great, great. I think respecting people, as you said, is the key. And you did talk about the lean being a culture rather than maybe a set of tools or techniques, which is a fundamental confusion in many minds. That if I know these tools and techniques, I can replicate what Toyota did. But what you're saying is that it is a culture. Of course, tools and techniques are important, but what is more important is the culture or the way, mindset or the way of thinking. So in this context, I have one more question for you in terms of, this is also a question being asked by the audience, that we talk about continuous improvement as also a part of lean culture, or I think they call it Kaizen. In this Kaizen concept can become a little abstract unless it is placed in the specific context. Can you give a little more clarity on this in this context of product development?
Yeah. So Kaizen is something which we should actually make people understand that they are actually contributing to the big success of the company in a small way. So Kaizen can be of multiple forms. One thing is, I see an improvement, I go and propose it and do it. The second form of Kaizen is, there's a bigger problem. Okay, there's a very big problem, but that problem can be broken down into small problems, and multiple improvements can become part of that, right? So a Kaizen is not a small thing. It can be an individual driven, or it can be a theme driven. So it can be an individual Kaizen, or it can be a theme Kaizen. But the net impact it creates is actually like a snowballing. It adds value as it rolls. But the key point to understand here is the difference between Kaizen and problem solving. So every company has a standard. They say that if you follow this standard, then you can actually meet these outcomes. Now, sometimes even by following the standards, you actually are not able to meet the given outcomes. That means that is an opportunity for problem solving. That means the standard is not good enough. So you have to solve the problem to bring it back to the standard. That is problem solving. Sometimes we may be delivering to standard, but there's an opportunity to do better. That is continuous improvement. So if we can see the difference between these two things, the right amount of focus can be given to the people, the right amount of support systems can be given to the people to go and deliver this.
So, taking you, I mean, we all know that companies, in fact, lean production also, you did mention that a lot of companies are following that. And we have seen that they seem to be able to achieve some results. Then there is some sort of tapering off. And then there is also decay. So same thing probably is also, unless, of course, we create strong, irreversible processes. How can we make lean product development more sustainable in the company context?
Yeah, actually, this lean deployment is not a one-time activity. It's like a garden. You put something, you have to actually nurture it and maintain it for it to evolve. Okay. Even otherwise, if you look at it, as I told earlier, the leadership in the business can change. The people who are working in the company can change. The company expectations can change. The customer expectations can change. So what you establish as a lean in a one instance cannot sustain by itself forever. Even if you go to our Toyota factory here, for a company which actually knows what it is, you will see classroom sessions happening in problem solving. You will see classroom sessions happening in PDCA, right? That means this things has to be reinforced, and it's like, you know, even to swim in the same place, you need to keep doing something or the other, right? So there has to be an effort to sustain it, and the key person who plays a role in this is the leader. The leader should live the principle on a daily basis. All the practices and principles which is being brought out as a part of the lean deployment must be first practiced by the leader, and it should be visible. And it should be practiced in thought, word, and deed. So they say Trikarana Suddhi, right? Mano, Vak, Kaya, the mind, word, and the action. So all these things must be synchronized with the model, with the philosophy which we are implementing the lean. And if the leader believes, and even the leader transitions, the right replacement should come in. When the new people come in, they must be trained. If this sort of a system, sustainability system is in place, then there is a possibility of lean sustaining it. Otherwise, it's high chances that it will fail, or it will fail.
Leadership in the context that you are mentioning, is it the top leadership or the mid-management leadership, or is it combo, or is it all? What is your thought?
It's a combination. So when you say leadership, what I mean is, that's why I didn't tell leader, I called it leadership, saying that the leadership team, because the leadership team actually, when you go through the system, they span over the whole organization. So somebody in the organization see at least one person in the leadership team. So their inspiration and their practice is very important.
So it's not necessarily the top leadership, but the whole leadership team.
Yes.
Must think and breathe, eat, live,
right,
lean way. Then only the organizational transformation can happen.
Right.
Great. But tell me, in your long experience of running this lean concepts, lean way of developing products, what do you think is, how can a company which is, say, non-lean, for a lack of a better word, how can they transition from non-lean to a lean? And what could be sort of be the challenges that they would be facing? And also, what type of time frames? I mean, does it take very long, or do you, in your experience, do you think it can be done in a reasonable time? Can you?
Yeah.
Get us
Based on
bit
my
more.
experience, let us say if you have a 200-member team or so, so deploying one cycle of learning of lean, that means you take up a big objective and then say lean is not just practices, you have to deliver results, right?
Yes.
So there are three types of results which is part of lean deployment. One is what is called a burning platform. That means something which is not allowing you to run the organization the right way. It's a problem area that has to be addressed. Your annual objectives have to be met. And the third one is you should be prepared to be progressing on your strategy progression. These three things are the objectives which the lean has to deliver in the first cycle of learning, which typically takes about a couple of years. And the first thing we do in that is actually bring up the leaderships, make them aware, make them practice, and then you take the team along with them. So once you do the first level and the people are actually, even the senior leadership, executive leadership actually sees, oh, this is not just a bunch of practices, this actually delivers results. Then you have to re-baseline it every year, then scale it up, and then deliver results year after year, following the same practices, refining those practices. Then you have a system, then over a period of say 10, 15 years, probably you can say you have a stable, you have a more reliable lean system.
I see. So you are saying, when can you start seeing the result? I mean, you are
Within
saying
the
15
within the
long
first
time.
7 or 8 months, you can start seeing the results, but they will be only they will not be big, but you will eventually see a burning problem which you have taken, which has been troubling you for several years, will get addressed, because whole company, the 200 people would know about it. There will be a contribution, there will be significant ideation, there will be significant changes, but all small ones. And since it's all focused, you will see suddenly a big progress, suddenly a people enthusiasm coming in, and this practice is adding on a daily basis. And it's a miracle, you know, it takes it takes some time, but it does work.
So you did paint a longish time frame. You said it will take almost 15 years. But say in the shorter term, say 1 or 2 years, would you be seeing some significant benefits to the organization?
No, first 2 years, you can see very big. What I say 15 years is for the culture to sustain.
Sustain. Okay.
Yeah, that means let us say in the 15 years, you have 3 leadership changes and so many new people join. In spite of that, if you're able to hold on to this, then we can say the system is sustained.
Wonderful, wonderful. Thank you. I think within a couple of years, we can start seeing the benefits. But can you sort of quantify and can you tell us more clearly what type of benefits, what type of tangible and what type of intangible benefits will they start seeing in this couple of years?
Yeah, there are a couple of things. One is it is a combination of strategic and operational. Strategic means strategic could be, I want to enter into this market, I want to have this set of products. So you can suddenly focus, resource it, balance it, do a strategy deployment and do it. That's a bigger part. Then on the execution part, it's again the quality, cost, and all the other things we talk about on an operational basis, which we normally focus on, right? Those things. So both on quality, both on our strategic and the operational side, you'll see benefits. How much benefits depends on what the team aspires. So it ranges. It's very difficult to give a specific answers, but depending on what you focus on as an objective, the system is there. The execution system is there to actually grind to it and actually make you deliver.
Would you say right first time would be a quantifiable benefit?
No, actually, in product development, right first time is not expected. Unlike in
no, I'm saying to the customer.
Oh, yeah. That's right. That could be one of the objectives. Let us say we have a product which the customer is disappointed. Many customers are disappointed when they open it, and that is one of your problems. That is more of an operational problem, which product development will certainly help. But you can actually dream very big.
Okay. So on the intangible side, what would be the benefit?
It will be predominantly people engagement. People
Nice.
engagement, people empowerment, your leadership pipeline, all the
Okay.
things which you are trying to do independently, it will come naturally, because that's
Nice.
how people engage themselves in their work.
Yeah, I think you have given us a very broad but also in-depth look. There is one interesting question coming up is in lean production. You did mention about this, but I'm bringing it out as a part of a question by the people also. In lean production, standardization of activities is considered a significant element of lean transformation. But in lean product development, as you said, the leader himself has to talk ambiguously, not specifically, and so on. So in that context, does standardization apply at all in lean product development?
Yeah. Actually, if you look at a lean production system, when you say standardization, it's standardization of work, saying that this activity should take 15 seconds or 16 seconds, and a bunch of activities that needs to happen so that it delivers in 16 seconds. And people are equipped and trained so that they're able to do it in this time. Of course, then there will be a continuous improvement. It could reduce by 2 seconds, right? But in product development, when you say standards, it is standardization of design, standardization of methods, standardization of knowledge capture. Okay. So when you say standardization of knowledge capture, this is actually another session by itself. Every product is made of subsystems. Every subsystems are made of components. That's if you can imagine a product that way. Knowledge of the product means for the whole product, for the whole subsystem and the components, we should know what are the limits, what are the trade-offs, and what are the causal relationships. It sounds so easy. I'm just telling it in 3 words, but this knowing this takes tremendous amount of experimenting, tremendous amount of analysis to say, okay, if this has to become, say, 20% lighter, okay, what will get traded off in this product? That is called a product level trade-off. Now you take this small button here. This is a component. If this button has to have some other feature, what has to be traded off? That's a trade-off. And in terms of limits, how many times can this button be pressed before it wears out? That's a limit. And causal relationship. If this behaves in a particular way, what all contributes to that? If it doesn't behave in a particular way, what all contributes to that? So there's limits, trade-offs, and causal relationships at the product level, subsystem level, and the component level. I mean, it's much more deeper than that. I'm just making it abstract. So if knowledge of capturing that knowledge is called knowledge capture, knowledge standardization, because in the future, somebody else can use it. These methods, design standards, and knowledge is something which anybody can use it. That is why it is called usable knowledge.
So in our manufacturing context, because all my life I have been a manufacturing guy, so we used to call it lesson learned cards of how one can, you make a mistake or you found some error, then I think that was institutionalized into lesson learned cards so that anybody else faces such a thing, immediately you know what is the cause or possible cause. I won't say the cause, possible. Right? Wonderful. Thank you. One last question. I know we are running out of time. So one last question, but this is a personal question. So I would like to, and I'm sure the audience is, because of your long experience in this interesting field, your own transition or your own life journey towards lean product development. Can you give us some insights about your key, you can call it the turning points, and also your advice to the learners or to the listeners who are joined us today as to how one can transition.
Yeah. So the first 12 years of my career, I worked for Japanese companies, one which makes products and one which actually does huge, large-scale engineering projects. So I was a techie for the hardcore nerd for the first 23 years of my career. So when I was going through the details of the design, I didn't think there is a system behind it. I used to just do the work.
Right.
Later on, several years later, when I started reading books about some of this, then okay, actually there's a method behind that, which is called as a lean product development. So as I was doing all these things and came into product development from projects, my leader at Honeywell, Dr. Krishna, told me that you need to do this across the organization. So that means I will not be able to go deep, but I should be able to do this. Then I said, how do I do it? I know how to do it myself, but I don't know. That's when all these books and thought leaders and all these things came. Then I decided that maybe I have to work with this. Then I worked with a lot of people. I've given some of their names in my PPT here, learned from them. We all worked together and started deploying it in some small, just like I said, test and experiment. We took a small team, a small testing team, tried this. We saw some phenomenal benefits. Then we spread it across. Then finally, it covered several thousand people across various countries where we could go ahead and do it. And the only maybe a personal thing is that I'm used to going deeper and deeper here. I'm actually spreading myself thin, but there is a satisfaction that a lot of people could get benefited by putting a method of doing things in a smarter way and the business getting benefited. And later on, I moved back into direct engineering, which is what I'm doing now. So it has been a mix, and it certainly that has been a great learning journey for me. Then maybe I'll take next 5 minutes. You talk about what I would give as inputs to the people. Again, so I have made a small presentation, which I think I want to share here. It won't take a long time.
You are a model man, so you have to model it.
Yeah, yeah.
Okay.
So the first thing was, see, when you are deploying such a system, right, there's always a conflict between tools versus systems. So when you deploy something, you have a principle, as you see on the left hand, some organizational philosophy, then you convert it into a bunch of tools and practices and do it. Eventually, over a period of time, what becomes visible, all the practices, what eventually matters is the management thinking, how it gets conveyed to the people. So the system focus is the bigger value, and the tools focus is the hygiene, right? And another thing is functional efficiency versus business effectiveness. Organizations are made of so many functions. Eventually, there are so many metrics which says how well my organization does. That is certainly a hygiene, which is very important. But eventually, what matters is how they all collaborate with each other and deliver a value. So between functional efficiency and business effectiveness, functional efficiency is the hygiene, but the value which comes out of that hygiene is the business effectiveness. Then there's always a question between managing by results. Managing by results is a hygiene because that is the accountability part. If there's no results, nothing matters anyway. But you have to manage means and measure by results. So none other than Edwards Deming says, management by results is like driving a car by looking at the rear view mirror, right? So you have to look at the rear view mirror, but you should know that you have already passed it, right? So the leading indicators are more important. And problem is an alarm. That is a hygiene. If a problem is there, you should get pumped up. But the bigger problem is having no problem. No one has more trouble than the person who claims to have no trouble. And no problem, being aware, no problem is a problem, is actually the bigger value, as much as we are alarmed by a problem. And leadership by control, certainly you need to have a lot of conference room meetings, looking at reports, looking at all those things, because they actually ensure that things don't fall through the cracks. But the real value is actually the leader goes to the Gemba, goes to work, sits with the people, works with the people, asks them the right questions, challenges them, spends time with them, and get the facts out, come up with the improvements and empower the people to deliver it. And finally, here I'm going to say hygiene is more important, saying that even some people may think discipline inhibits innovation, but certainly this may be a boring thing, but I certainly believe that discipline is the fundamental to everything. So the price of discipline is always less than the pain of regret. So if you're asking me to give some advice, maybe I cannot give my advice myself, but these are the general learnings, what I thought or makes sense, and I'm sharing it to the people here.
Wonderful.
Thank you.
I think if you can leave this slide for a few more seconds, then these people can absorb this, that the key lessons that you have learned over the years, you have captured it in this wonderful slide. And those 6 lessons are invaluable to all the people who have joined us today. And thank you. I think you talked about what is a hygiene factor and what is a value add factor. And I think if people, it is not either or, both are required. But hygiene is a means, but we need the value which the end customer needs it. Wonderfully put. Thank you very much. And we will be very, I just wanted to inform all the listeners that Mr. Jayaram is an extremely open person, as you have already seen it today. He is willing to share his own experience for all our benefit. So the email ID will be shared with you in the chat session. So please do contact him in case, because he himself has offered it, that he is willing to answer your questions in this very difficult to find a person like Jayaram, who has built up such expertise, but also is so humble. Very difficult combo. So thank you very much, sir, for being with us and sharing all your experience with our people. And we look forward to continuous interactions and also partnership with MIJSC.
Thank you very much, sir. Thank you very much for the opportunity. Namaste. Thank you very much.